Hello everyone. Today I'm gonna give a presentation of my computer vision project, Color Image Enhancement by Histogram Equalization. This presentation mainly involves 5 aspects: the problem under study, related work, proposed approaches, performance evaluation, and summary. The problem to be addressed with is that in our daily life, we often encounter situations that when the light condition is not that good, for example, when we take photos at night without extra light source, we cannot see the details in the image clearly, like figure 1. We are not able to see the details in the flower, so we need to develop methods to cope with this problem. And my approach is histogram equalization. Histogram equalization is to change the grayscale histogram from a relatively concentrated grayscale interval to a uniform distribution in the entire grayscale range and redistribute the pixel value of the image. Let's see figure 2. The left photo is the original image, and the right one is processed by histogram equalization. Obviously, the right photo is brighter than the left one, and we can easily observe the details in the flower and background. Here are related works. There are 2 main categories in image enhancement: histogram equalization, HE, and histogram matching, HM. Histogram equalization aims to find a gray level transformation relation so that the occurrence probability of gray levels of transformed gray images is the same or similar. According to mathematical theory, the cumulative distribution function can be used as the transformation function to produce an image with uniform distribution of gray level. Figure 3 shows a gray image, the processed images, and their histograms. The first image in the left column is the original gray image. The middle one in the left column is processed by adapt-his-tag function in MATLAB, which enhances the contrast of the grayscale image by transforming the values using contrast-limited adaptive histogram equalization. And the last image is processed by his-tag function in MATLAB, which transforms the grayscale image so that the histogram of the grayscale image is approximately flat. The advantage of HE is that it can be fully automated without human involvement. But its disadvantage is that it can only generate a histogram that is approximately balanced. Sometimes histogram matching is used when people want to modify the histogram of an image to match a given histogram or to have a performed function shape. Figure 2 shows the result of histogram matching. From the result, we can easily arrive at the conclusion that the contrast of the original image has been greatly improved, and the detail in dark area are able to be observed after histogram matching. But as mentioned before, it can only form a histogram that is not balanced precisely. Here we come to proposed approaches. In this project, I applied histogram equalization on RGB, green, red, green, blue, and HSV, hue, saturation, and value. For RGB, the progress is to extract RGB channels from a color image and calculate the gray value of the original RGB channels. Then apply the histogram equalization on each channel with HE function respectively, and calculate the gray value of the processed RGB channels. Finally, synthesize the processed image and output the result. For HSV, the most important parameters of this model are hue, saturation, and value. As for the specific topic in this project, value, as known as brightness, is the most concerned feature among HSV, and we can only enhance the V channel. First, convert RGB channels to HSV channels, and then apply HE on the V channel. After HE, convert HSV channels back to RGB channels. Here is performance evaluation. The left figure is the original image, and the right one is processed by HE and RGB channels. As we can observe, this method greatly improves contrast of the original image. However, there are several drawbacks. For example, overexposure appears in the light area, especially near the blue light. Besides, HE distorts the corresponding color, such as making this blue to purple and here blue to nearly white. Compared with the original image, this approach also enhances the contrast and makes details more clear to be observed. Moreover, unlike RGB channels, HSV channels provide higher degree of color distortion, which means the corresponding color in the original image does not change too much. Furthermore, there is less overexposure than RGB channels. And to sum up, the two methods both enhance the contrast of color images and significantly improve image quality. But overexposure happens in both approaches, and there is color distortion in RGB channels. So in other words, after comparison, HSV works better than RGB. So personally speaking, HSV is more recommended. Thank you. That's all.